right, some students have been running into some trouble on screen 4, so I want to clarify a couple of things about the confidence intervals activity for you all. First is screen 2. While you're working on screen 2, what you're supposed to do here to get to your 50 tosses is to press the toss button and then count the number of kisses that land on that toss straight up. So land, I guess they call that face up. So land on their bottom. So in this case, just 1. And you'll toss again, and thankfully the background changes. So even if the kisses stay the same, you know that it's actually tossed. And you'll do this 10 times. And after the 10 times, you will, okay, just 1 again, you'll have tossed 50 kisses. And so this is just trying to be a little more efficient with what's going on here. Woo, I got lucky 4. And making you not press this toss button 50 times, because I've done this before. The version of this activity I had made before I stole one from my friend Bob Lachelle actually had you click that toss button 50 times. So this is a little more humane, a little less sucky. Okay, that's 0. And in terms of doing it, you only have to do this 10 times, recording how many land on that bottom each time. So once you're done with that, you move on to the next screen. And it tells you how many. It actually adds those all up for you. So this number 15, this is your number of successes out of your 50 trials. It should be less. So if you got overzealous with those 50 tosses, you might have ended up with something larger, which kind of breaks the whole activity. So some people landed in that boat. Once you finish answering these questions, as you choose things here, like, maybe it gives you more stuff as you press submit. So make sure you're pressing submit and not just typing, because there are more pieces to this screen that appear as you go. But screen 4 is where we're running into a lot of trouble. Screen 4, I think it is just kind of the wording here. It's kind of mathy in terms of what we're calculating. We're calculating 2 things. Well, actually 3. But the first thing is to calculate our standard error correctly. And all a standard error is basically rewriting our standard deviation formula, but using our statistic instead of a population parameter. So we don't really know what P is. We don't know what the true proportion of kisses that are going to land on their bottoms is. And so we need to estimate this using our sample value that we had of 0.3. So we know our P hat is 0.3. We know our N is 50. And we're just going to plug and chug into this formula. You can enter this as math. So I can just start typing square root. I happen to know SQRT gives me square root. 0.3. I'm going to do the 1 minus 0.3 in my head, because I'm just used to doing that complement from part 4, the last section we just did. And that's all divided by 50. Make sure everything is inside of your square root symbol. If that's true, you should get out a nice pretty number. You can press submit. It'll tell you if you got this right with an emoji. And if you got it right, it'll show you the second step, which is 2 calculations. And again, I think the mathy words that Bob used to describe this upper and lower bound are a little tough for students, because essentially we know some stuff, right? We know that our value we expect to be at the center. Well, we don't know what the real P is, but we could use 0.3. We don't know what the bunny hops are, the length of them, because we don't have the real P to get a standard deviation, but we could kind of make something up using the standard error. And so we are going to go out 2 bunny hops, except not exactly 2. We're going to go out 1.96, because that'll get us an exact 95% within that sort of range if it were a standard deviation. So that's what they want us to do here. Lower bound, we're going to take that P hat. So remember, our P hat for me, yours may be different, was 0.3. We're going to subtract 1.96. And I kind of wish he had put times the standard error, but 1.96 of these standard errors. So we'll do times, and then that's when I'm going to have to go back up here to see what it was. 0.0648. So 0.0648. And that'll give me a value. And I'm going to do the exact same calculation for that upper bound. In fact, I'll just copy and paste, except for it's going to be a plus. Oops. And as soon as those are both correct, you'll get this little happy face emoji. So if you haven't seen that, you've probably only got 5 out of 10, and that is exactly why. So some people just added and subtracted the actual the 0.648. Some people, I think students might have done the order of operations incorrectly, might have done that minus 1.96 and then multiplied. Not really sure, or they just didn't see the standard errors piece, so they just subtracted 1.96. But your values should be 0.3 in the center and then just a little bit above and below, because you're going to end up with this interval of kind of feasible values. So just wanted to give you all a heads up in case you were stuck on screens 2 or 4 for this assignment.